All right. Welcome everyone once again. Please have a seat as soon as you can because we're about to get started. Next up, we have, let me bring up the bio once again. I always forget. All right. Cool. Next up, we have Marcelo Trylesinski. Marcelo is an open source developer who has made significant contributions to the Fast API community. He maintains Starlate, a critical dependency of Fast API, and Unicorn, a high-performance web server that powers Fast API applications. His invaluable contributions led to his hiring as a senior software engineer by Pydantic, a widely used library for data validation and serialization. Apart from software development, Marcelo enjoys fitness, soccer, dancing, and photography. That's awesome. He's a well-rounded individual for sure, who's always eager to learn and grow. Please, everyone, give a warmest applause and welcome to Marcelo. Give it away.
Is it working? Yeah. It was ChatGPT based, so like the description. Hope you like it. Okay. You're gonna sit? Okay. Should I wait for you? No, I can wait. Yeah, so just a question before we start. Is there someone from South America here? ¿De dónde sois? Okay, nice. Okay, so this talk is going to be in English anyway. And I'm going to talk about, well, the validation evolution, the Pydantic V2. So, does anyone here doesn't know what Pydantic is? Doesn't know. Yeah, still know. Yeah, so anyway, so if you don't know, this talk's going to be nonsense, but if everybody knows, that's going to be fine. So I'm Marcelo. I'm from Brazil. I live in the Netherlands. I did help Fast API for the last 3 years and a half, mainly helping on GitHub issues, discussions, triaging stuff, and also some small pull requests, but mainly helping the community. And I'm also a maintainer of Unicorn and Starlet. Unicorn is a web server that runs applications that look like Fast API. And Starlet is one of the dependencies that manages all the web framework-related capabilities of Fast API. I've also joined Pydantic. That's kind of why I'm giving this talk. So we raised something. We raised money this year, and then Samuel created the company, and he hired me 6 months ago, 7. And we're going to be talking about Pydantic, what happened from V1 to V2. It's more about API changes. It's not going to be about the Rust thing. So I don't code in Rust. I don't know Rust yet. But it's going to be mainly the API changes that happen from V1 to V2. Yeah, so what's Pydantic? Pydantic is a data validation parsing coercion library. Samuel already agreed that Samuel is the creator. He already agreed on this concept, how to describe Pydantic. And well, this is the basic. You create a model. Sorry, everybody really knows Pydantic? Amazing. So anyway, so this is how you do it, the beginning. This is how you start. And this would be how you create, well, start already thinking about the questions, because if everybody knows, I'm going to have a lot of time for questions. So think about them later. This is how you'd create your model with some more validation capabilities. So if you see on line 5 and 6, I'm adding some constraints. I'm saying that integer on line 5 is going to be greater than 0. And on line 6, I'm saying that the max length of this string is going to be 10. And then I show a bit how this happened in Pydantic. Yeah, so this talks about the changes that happened from V1 to V2. That was just the basics. Now we're going to go to the changes that happen. Yeah, everything that I'm going to say here, it's on the migration, on the Pydantic documentation anyway. I'm going to say some new stuff that were added recently, and I'm going to also give a bit of performance tips at the end. But everything is documented, nothing is hidden. So why did we create Pydantic V2? There were a lot of issues from old times, like from the last years that Pydantic was created, and there was a need to change the API in many places. So this was one of the reasons, and the other reason it's because, well, there was the need kind of thing Samuel wanted for Pydantic to be more performant, so he created the core of it in Rust. So we have the Pydantic core and the Pydantic. So the library Pydantic was divided in more things, in more blocks. So you have the Pydantic core that is in Rust, and then you have the schema being created there, and then the validation being done in Rust, most of it. And so this is the library that was created for that. So we have this Pydantic core, and there is a binding using the Rust binding. And then, well, Pydantic core was born. And also there is another small library that is used called annotated types. That is another dependency of Pydantic that uses some custom created annotated types. So if you know annotated in Python, there are some stuff that is being done on that library. So for example, max length become a metadata to use in Pydantic. So you know when you do annotated and then you have the type and then the metadata that can be added. So we have a lot of that in the package called annotated types. It was a package created by Adrian, Samuel, and the hypothesis guy that I forgot his name. The one that knows type analysis stuff, you know, someone? No? Okay, anyway. So if you look for the hypothesis, you look the first one, he helped, they worked together to create this new package, and if you look at it, it's just about a lot of metadata for annotated, which is used in Pydantic. Let's go through some changes. The first change that was being done and why it was being done was the config. Well, the first change, one of the changes, is that before you'd use the config class on the base model, and now you don't. There were some problems with this. Well, the main problem is that it's not very developer experience-wise, because you don't have auto-completion when you are adding the fields, right? So typos would be just ignored, because if you have new attributes there, would just be ignored. But with Pydantic V2, we have this model config, which you can use the config dict, which is a type dict, and then you have the auto-completion, and you have also your type checker is going to identify if you have any field that isn't supposed to be there as well. Another thing that's important to mention here is that on Pydantic V2, we added a lot of, well, all of the methods and all attributes are going to have the prefix model. That created a bit of conflict on some cases because of the AI world and stuff, but you can change this model prefix namespace that we call for another if you want. If you look for protected namespace on the settings, you're going to see this one that you can change. Use something else so you don't have any issues. So I say this because if you create a model prefixed, if you create an attribute with model prefix, then you're going to have errors, warnings. Anyway, so some things that also changed. We've renamed a lot of stuff. Everything that is there was actually deprecated from V1 to V2. And I was saying earlier before this talk, we did this so it makes more sense. But everything that is on the left also works right now. It's just with the deprecation warning. And then the names were just changed because it makes more sense for V2. Another change that happened is on the validator name. We also changed the name of the validator to field validator. This change was also because the naming makes more sense, but new things were added for this field validator. So if you see how it is right now, it is comparable, the same thing. I just changed the name, but you can have another signature of check, and you can provide like more information. There is more metadata information about what you can do here. So pretty much a lot of changes. They are pretty similar, but they add a lot of things that you can do. So you can now build more where before you couldn't. So this is like if you see the idea is that you maintain the developer experience that you had before, but you add more. You are more capable to build more complex stuff. So I just showed what would be the analogous, but you can do more now. So yeah, so one of the things that you can do is that you have now 3 types of modes that field validator can be, and one of those is the before. So the before means that you have the validation on the field. So if you see on line 5, you have field greater equal than 0, which means that the type validator is just going to check if that's an integer and it's greater or equal than 0. With the field validator before, it means that this validator for lines 7 to 9 is going to be executed before the type validation. So it means that on line 12, I call this a equal receive equal -1, and then what happens is that I execute from line 7 to 9, so it adds 1, so it's 0, and then on line 5 is when I execute that validation. So it means that this is not going to error. There's not going to be a validation error here because -1 plus 1 is going to be 0. 0 is greater or equal than 0. So this works. Another way to write this down, and it's kind of our recommendation on the, well, it's our recommendation, is to write it as an annotative type. So as you can see, on line 9, you have my int, which is a non-negative integer, and I'm adding this before validator, which just adds 1 to that value. So this is analogous to what you see on the previous slide. So this is more how it would look in V1. This is more how you should be coding in V2, because actually you can reuse this myInt in several places. So it makes more sense, it's more cute, because if you imagine this, it's going to be like, this myInt is going to be somewhere module that you have all those new types, and then you have this line 13 on this other module, and then you organize things pretty cute. Yeah, so you have the before validator, you also have the wrap validator, you have all the metadata types like before validator, wrap validator, and the next one I'm going to show you on the next slide. So you have all of them, you can use them, and you can also use on the field validator. So if you have the mode, you have the 3 modes that you can use. Yeah. So here what happens is, if you see on line 7, the validate timestamp, you actually receive a callable. So this handler is going to be used to call the type validator. So if you see to verify that it's a data time, we're going to actually run the handler. So what this validator is doing is just to give you context if you don't understand. So on line 8, I'm just checking if it's the string now. So that's going to happen before the type validation. So if it is, I'm going to give the time of now, data time now, and then it's going to end there. If not, then I'm going to execute the data time handler itself, the type handler, and then the type validator, and then I'm going to return that. If there is an error, if it's not, if it doesn't pass, if it's not a data time, then I'm going to return what we see on line 13. That's a wrap validator. I didn't mention this on the slides, but the wrap validator, one of the tips that we have for performance is that if you don't want it to be, if you want your software to be more performant, you should avoid those. I mean, obviously, if there is a use case for it, go for it. But the thing about V2 is that we have many ways, maybe not that Python's in, but you have many ways to do a lot of things in Pydantic now. We do have a lot of recommendations, and if you see the documentations, they are very... Gracias. Anyway, let's go. On after validator. So, gracias. So you see, this is analogous to the other the other two. So we have before validator, wrap validator, and you have the after validator. The thing that's different here is that you're going to have the type validation happening before. And so if you see on line 11, you have a equal 1. Then we're going to call the type validator of int. So we're going to verify that it's an integer. And then after, we're going to do the v plus 1. So we're going to have, yeah, you can use lambdas as well. It's fine. Huh? So this is going to be at the end. It's going to print. I cannot see it. It's 2? Yeah, 1 plus, yeah, perfect. So it's 2. Okay, good. Another change that happened was on the naming of root validator. So it actually makes more sense. So a lot of changes, as I said, they just make more sense on the naming part. So root validator becomes model validator. They also have the 3 modes, so you can use the before wrap and after. Yep. And this feature was used a lot on V1 with Fast API. How many people have used this root thing? Well, some people use this feature. And the idea here is that the base model kind of changed its type to be what you see on the online 5. So this path is going to behave as if it was a list string. So if you see on line 8, if I am validating a string of, a list of strings, that's going to work. And then I'm going to have, if you see on line 9, if it's not too bad, that it has the value of dog and cat. Yeah. And the JSON schema that's generated is an array, and the type of the items is a string. And on V2, what we did is it looks a bit more cute, is that we have this root model. And as you can see, it's just a generic there. You have the list string, and you can use it like this. If the type is a bit more complex, you can also inherit from root model and then create. I didn't show it on this slide, but you can see on the documentation if you look for root model. But this would be the simplest way to implement this. So this is completely analogous as what you see here. So you just have line 4 and 5, which you have the type of root. And on line 3 here, you just have what would be the same thing. Looks cute. Anyway, so the type adapter is a new feature of V2. We didn't have anything similar on V1. It's a feature that the team is very proud of, and it's a way to validate the type, any type that that Pydantic supports. There are some types that you need to. I'm going to explain at the end, some slides, but you need to add some more stuff for Pydantic to understand what it needs to do. So here, if you see on line 7 to 9, we just have a type dict, name and ID fields, and then on line 11, I am going to create this type adapter that has the type of list user, and then on line 12, I'm going to call validate Python, which validates the data that I'm passing there. So yeah, what else? Base settings. Who used base settings? Okay. No, that one I was expecting more, but it was more on the root thing. Anyway, so actually Sebastian, the creator of Fast API, didn't like much about the root thing, and I also didn't like much about it. But so some stuff we're actually not working with root thing on Fast API. Maybe because it was kind of not like there was no people shouldn't be using as much as they were. But on V2 things are working more. Like if you use Fast API with V2, Pydantic V2, things work more properly on the generation of the OpenAPI JSON schema. Anyway. We just moved some stuff outside Pydantic. For example, the base settings. The idea was to have alleviate a bit what Pydantic does. So the base setting was moved to this package called Pydantic settings. So this is the point that I wanted to mention before. On Pydantic V1, you'd use modify schema to modify the generated JSON schema. On Pydantic V2, that changed. So this is one of the things that, if you look at it, the basic stuff, it's very similar, but you can make it far more complex. So I'm just going to show you, like this just adds a field called examples on the JSON schema. And, well, this might be a bit more complicated. But anyway, we have this get Pydantic JSON schema that does the same thing as the previous one. So you have the core schema. It's the schema that is created on the Rust side, which contains all the information that how we're going to validate those fields. And if you see on line 13, I'm just calling the get Pydantic JSON schema from base model. Actually, I can remove this line because when you are, yeah, you can just remove it. It's not doing much. not doing anything, if I call it like this, I think. And on line 14, I'm calling this resolve ref JSON ref schema, which is going to create this schema. And on line 15, I'm just doing the same thing as I was on the previous slide. So this is far more powerful than what you saw, or what we could do on V1. Even if it looks a bit more verbose, a lot of people were very happy about this because there is far more things that you can do. You can read more about it on the documentation. We have a full page about it if you need to. This is only useful if you really want to change the JSON schema that's generated. Did someone use this before? No? Okay, so completely useless. So you might use on some cases. That's also very useful if you are creating a library and you create this custom type, and then you want the schema, the JSON schema, to look something that you want. So that was the fullness of it. Same idea, but since you didn't use, well, actually this one some people used, right? Who used this? Okay, some people used. So you didn't care about the JSON schema, but you did care about those custom types that you have created. So this was one of the ways, well, was the way to create those custom types. So if you see, you have a username that's a string, and then we are adding more validation to it, kind of. So you see that on line 6 to 9, I have, I'm just checking if that username has all characters being alphanumeric. How you do that on V2 is a bit more verbose, maybe more, slightly more complex, but once you understand, there's a bit higher learning curve, but after you understand it, you can see how powerful it is. But it's more also to, well, those who are maintainers of packages do have interest about this. And also some companies might use this. There was a company that I worked that used this all the time. So this might be useful for them. But pretty much if you look at line 12, you have this no info after validator function. So the idea here is that you have two kinds of signatures. One is with info and one is with without info. So we are using no info here, which means if you look to line 17, you see that you just have the value being received, right? And if you have with info, that would be another parameter being info, which would provide some information about the type itself. So to add more, well, you could use to do more. You can just add another one and then change the name of the line 12, and then you can see what happens. But there are many other functions, not only no info after validator function, but there are, like for example, no info before validator function, no info wrap validator function, you know? There are all of the modes that I've talked previously. Yeah. So there were also some types on Pydantic, for example, the color, and what else? There was another type. Anyway, the color was in Pydantic itself, like, you know, when you have someone use the color thing, the color type on Pydantic? Well, I guess not business very used. Anyway, there was this type called color that was moved to Pydantic extra types, and there are some new custom types that are implemented here. For example, I think there is IBAN related, there is color, there is country. So if you have the like 3-digit country, for, I don't know, 2-digit, like, you know. There are some types being implemented here. This is also documented in Pydantic itself. And we still don't have a strategy on what should be in, because actually, right now, if you implement the get Pydantic core schema, this method, we actually don't need to put it on Pydantic extra types, because everything, you can just create types by your own, and everybody can use it. So it is, everybody can create those custom types and share with a lot of people. So some performance tips now. I left it to the end, so those who are leaving cannot see it. It's okay, it's okay. I made them feel bad. Anyway, so one thing, The model validate JSON. So there are two main methods that you have. One is model validate, and the other is model validate JSON. One receives a Python object, and the other receives a string or bytes. No, a string. So in this case, you see on line 9, I'm just adding this JSON with A and B keys, with integer and string there. So here, what we saw people doing was to use the model validate and actually doing the JSON being loaded. So the thing is, Pydantic itself, underneath on the Pydantic course part, already does when it is doing the JSON, when it's reading the JSON, it's already doing the validation. So if you use model validate JSON, the validation is already happening, and it's far more performant than doing what the second part of it. Another thing that we saw, we actually mentioned on the documentation, is that people that are using the type adapter, so again, the type adapter is to validate any kind of type that Pydantic supports. So if you see on line 7, I have this type adapter. And also, if you don't know, type adapter is what FastAPI uses underneath to validate the data. So yeah, it's good. And why? Because you actually can use type dict, you can use data classes, and then you can just use the type adapter, and then everything works as expected. The tip is to just instantiate it once. It takes a bit of time if you need to instantiate it all the time. So here you can see an example, line 7. Every time I call this function, I'm actually creating a type adapter object. You shouldn't be doing this. You should be maybe a global or caching somewhere. I don't know what your strategy is going to be, but you should not be calling this multiple times because it's going to be very resourceful. So you shouldn't be doing it. Another thing is, yeah, so this is kind of, people usually don't think about it, but if you are not, is it fine? ¿Está bien el tiempo? No. So, sorry, you should, dime. ¿Quieres que hable más? Le explique mejor.
O sea, que expliques como qué es lo que se ve, porque hay gente que no lo ve.
¿No puedo agrandar esto? No. Sorry. So there is a base model there. With on line 7, I have an attribute with type any, and the thing is, if you're not interested in validating an attribute, you should just use any, and then that type is gonna be what you receive. It's gonna be passed to the model that you're creating. So this is another performance tip that we are recommending. There is a benchmark that we have, and also we have a page called performance that was added last week. So if you go to the Pydantic documentation and you just see it like it's written there, performance tips on the first page, and then you can see more tips. And this is one of it. I don't know if I've ever knew about why, so I'm not gonna say it, but you can ask on the discussion there on Pydantic. But anyway, if you use literal, and it's gonna be more performant than enum, about 2-3 times faster, if you really care about performance. Another thing is, I was just saying, yeah, I told you, right? So if you have a lot of base model nested ones, you should be using type dict. That is a bit more, again, 2-3 times faster as well than having those base models. This is because the base model is a more complex object. Type dict is far more simpler than that. It's just a dictionary. Anyway, if you want to see, as I said, if you want to see other performance tips, we still need to improve a bit the page. It's a new page we created last week, but it already has some stuff, so you can see it. People love performance. So another question that people are doing it, is V3 planned? Yeah, it is planned, but the changes that we're going to do are not going to be as breaking as it was from V1 to V2. That isn't going to be Like Pydantic core is going to still be there in Rust, and it's not going to be that breaking. So we are cool. Where to see more about it? So if you go to the documentation, we have a page on the migration that you can have far more information about everything that I said, but also more stuff. Also, we're creating a product at Pydantic. It's it's an observability tool focusing on developer experience. I have a lot of cards here, so if you want to see it, just talk to me, and then I'm going to give you a card. Yeah, that's it. Yeah, wait. Yeah, I'm going to the beach, so be faster here, so. Okay. Anyway, follow me on YouTube. I have my YouTube channel. It's the Fast API Expert. And thank you very much.
All right, great talk. Thank you, Marcelo. So now we have approximately 7 minutes for questions, so we have right enough time to go back to the main hall for lightning talks coming up at 5:30. So please raise your hand. Anyone that has a question, let's try to keep them sweet and short, guys. All right, over there.
Hello, Marcelo.
Hola.
It's been a great talk, and I wanted to thank you for this talk. It's been really insightful. And I've been using Pydantic V1 for the past year, and I wanted to ask you if in V2 we still have differences between Python 3.9 or previous versions as in terms of typing. Like, for example, prior to Python 3.9, we couldn't use the list native Python. We had to import from typing. But after Python 3.9, we could use it just fine. Have you encountered some of these issues while moving to V2, or are they unified now?
No, that's going to fail anyway. But that's because of Python itself, not because of Pydantic. Because Pydantic is it's doing type things at runtime, so anyway, that's going to fail.
Okay. Okay.
Like, we cannot do anything about that. That specific case that you say, we cannot do anything about it.
Okay, yeah, but it just works the same as V1.
You mean
right?
fails the same?
Yeah.
Yeah,
Yeah.
yeah, it fails the same, yeah.
Yeah, okay. Thank you.
You're welcome.
All right, next question. Anyone? Over there.
Hello. Thank you for the talk. I don't know if you say that, perhaps a bit stupid questions, but how much is the speed improvement between version 1 and version 2 in validation? So to understand if it makes sense to do all the needed changes to get the performance boost.
I think there is a range that we usually publicize, like kind of thing. I think it's between 5, like depends on what you're doing, right? So it's, I think the numbers that we share is from 5 times to, I think maybe, I'm gonna say any number because I don't remember the exact number, but I think 100 or something like that. It depends on the case. I don't know. You need like, I can check with you later, but it's a good idea.
At least 5%, 5 times.
5 times, not 5%. It's far more.
Yeah.
Yeah.
Thank you.
Yeah.
All right, any other questions?
Thank you very much for the talk. I'm curious, you mentioned several times during the talk, like, have you used this or that feature? This is kind of a meta question, but are you considering analyzing like GitHub repos or something like that to really understand what features of Pydantic are people using, like to prioritize maybe in the future or things like that?
No, I never thought about Pydantic itself doing that, but I did think about that on the other packages, like Starlet and Uvecorn. That would be interesting for me, personally. But I didn't think about that. Like, you know Pants build, the monorepo build system? Someone knows Pants here? Who knows Pants? Okay. Anyway, it's a monorepo build system thing. They do use the anonymous telemetry thing, maybe that's the name in English. I don't know. They kind of track features and they obfuscate stuff and they analyze what's being used or not. I don't know if they still do that. I don't know if they do exactly how I said. But that's a good idea, like to check the repositories. Good idea. Okay, thank you.
Awesome. Anything else? We have maybe 3-4 more minutes for questions. Okay.
Thank you for the talk. I would like to ask, how would you compare the data classes of Python and the Pydantic in their job or in their mission? How is it comparing, or what would motivate me to migrate from data classes to Pydantic?
Well, one would say that's completely different. But if you are in need of validating your data, doing parsing, coercion, then you should, because data classes don't do that. So,
Okay.
like yeah. Sorry, I'm not sure if it answers.
Yeah, I think, but it may, in certain points, their mission is almost the same. Well, not in the validation, but in the wrapping an object.
Yeah, but then
You have modeled it, yeah.
yeah, but then a potato is a potato, and
Yeah.
you know, it's like
Yeah,
I mean, not being rude. It's just that
Yeah.
the use case of it is specifically what you said is like it's not the just part. It's just the job the tool is doing. Like it's the core thing. If so, the way I perceive the question, not trying to be rude, just saying, like the way I perceive the question is like, if I remove the core job of it, isn't it the same thing? I guess, but not the idea, you know.
Okay.
But we can talk more about like, you know, but that's pretty much the answer. Yeah.
Okay, thank you.
All right, thanks everyone. That's a wrap. Big ovation once again for Marcelo.
Thank you.
Cheer it up.